Okie dokie. Pause and copy and try the exercise. Beep, bop, boop, bop, bop, beep. Okay, so the idea is that this number is the row number, and then this number here is the column number. So for A32, that's third row. So third row, second column. So you have -1 here. And then for 1, you have first row, first column. So you have just the 1 here. Okie dokie. Sometimes we will want to talk about A in terms of its columns. I think I've done this before, but I'll repeat. So it has 2 columns, so I could write it like that. And you could say that A1 and A2 are in R3, aren't they? Okay, so these two things are the columns of A. Okay, so we have a few special matrices. Let's go definition. So you can have what's called a diagonal matrix. Okay, what it means is that off of the diagonal, you have zeros, only zeros. On the diagonal, you could have anything. You could have zeros on the diagonal. Okay, so even if that's a 0, still a diagonal matrix. Okay, then you have the 0 matrix. These are zeros, not your weird looking zeros. It's called the 0 matrix. What else? Oh, we have the identity matrix. 1, 1, 1. So the identity matrix is a diagonal matrix. And in this case, you would say this is equal to, you call it I, or I4, if you want to indicate that there are 4 rows and 4 columns. What else should I say? Okay, this matrix here, we say this is a 3 by 2. This matrix here is a 4 by 4. And this one up here would be a 3 by 3. Okay, same convention as before. The first number is the number of rows, and the second number is the number of columns. Okay, when we have two matrices of the same size, you can add them together in the obvious way. Okay, you just add corresponding entries. Let's make sure I'm not screwing up these additions. So yeah, just do the obvious thing. This is how we will define addition. So it's good to double check these simple little calculations because, as you know by now, this class is filled with them. And I hope you're not using your calculator. It's not gonna end well. Okie dokie. If we have matrices that are different sizes, you know, we just refuse to discuss this at all. And just say sum does not exist. Okay, scalar multiples. Okay, so again, you do the sort of obvious thing. If I have 2 times a matrix, 1, 2, 3, 4, minus 3, minus 2. So we're going to define the product of a real number with a matrix. Okay, we're going to call this a scalar multiple of the matrix. And we do the sort of obvious thing. We just multiply every entry by whatever that scalar is. Okay, you should see theorem 1. It collects some properties. For example, if you have a number times a matrix plus a matrix, you get the distribution that you're probably hoping for.